Variable potential divider. This is a new title within the same chapter. It is also called PD controller. Give this heading. So let's make the concept variable potential divider. Let's make the first concept. It is a circuit component used to obtain a fraction of voltage from the total input voltage. What's the meaning of this concept? Circuit component used to obtain a fraction of voltage. It means that it's a circuit controller. You must have seen these type of circuit controllers which are controlling the speed of the fan, which are controller for brightness, sound, control on contrast, sharpness, etc. So these are the common controllers in our life, and you must have seen it. We normally call it dimmer, or sometimes we call them regulator. This is a common picture of it. In physics, these type of controllers are called variable potential divider. These are called variable potential divider. So first you copy down the definition. It's a circuit component. This definition, copy the definition. It is a circuit component used to obtain a fraction of voltage from the total input voltage. What it means that actually it is a type of voltage breakup. Now you are getting to 20 volt, you want to decrease the voltage to a fan because you want to control the speed of the fan. So you will use potential divider. This is called a potential divider. We can also call it a regulator or a dimmer, but physics we call it potential divider. Now we have some examples. You have to copy down these examples. Now let's talk about the working rule. Now, the very important concept comes here, that how potential divider works. It is not a device, it is actually a circuit. So suppose that this is a 10-volt power supply and this is a resistor. Now, if it is the only resistor and there is no other power loss, this resistor will get the full 10 volt. Now, if I attach a similar resistor with it in series in the same circuit, look at the same circuit. Now what will happen, that it will get 5 volt and it will get also 5 volt. This is called voltage breakup. And this circuit is simply a series circuit. So in order to break the voltage, you have to connect the resistors in series. Now, after breaking the voltage, you make a connection point here. This is one wire and this is the second wire, and you come here. So you can draw this 5 volt outside using a pair of wire. So a potential divider, is actually a combination of resistors in series. A potential divider is a combination of resistors in series. This is how a potential divider works. This is how a potential divider works, and it divides the voltage by using a series combination. Now you have to copy this. A potential divider it's simple, Asad. I will try to explain it again. First, you copy this. A potential divider uses resistors in series. Now, in a series circuit, current is always constant. Let's talk on this topic a bit more again. In a series circuit, current is constant. So voltage is proportional to resistance. So when you have a single 10 volt resistor, it will get all the voltage. On a 10 volt supply, if you put two resistors, they will divide the voltage. If you put three resistors, they will divide the voltage in three parts. So as you keep on increase the resistors in series, you can divide the voltage further. Now, then you have to use a slider. What is a slider? Slider is actually the knob which already we know we can move it. It is like a jockey, like a pin. You can slide it, you can move it to get the new position. Like when we are sitting in a car and we want to change the speed of the air conditioner fan, so we move the slider. It's a round shaped slider. So we divide the voltage. First, we divide the voltage by using resistors in series. This is 10 volt, 5 volt here, 5 volt here. Now this 5 volt will come out because the slider is making a combination here. This is how we can change the position of the slider and we can change the output voltage. So slider mechanism works on resistors in series. You have to copy this now. In a series, volume and resistance, sorry, voltage and resistance are directly proportional. Now, potential divider uses this formula. This is coming from O-level maths. This formula is a famous O-level maths formula, ratio upon sum of ratio into total. Now, you have to copy this O-level maths formula to be used here. Now, potential divider circuit. This is called a potential divider circuit. How this circuit works, these are the two resistors in series. Now, suppose that it is 10 volt. This is suppose 7 volt. Then I put a question mark here. How much R1 will be getting? R1 will be getting 10 minus 7, the remaining voltage. So R1 will be getting R1 will be getting 3 volt. Look at this slider. Look at the second wire. So it's a parallel combination. So this 3 volt will come outside as the output voltage. So how we make a potential divider? We connect resistors in series. We connect resistors in series. Then we connect a slider. Then we connect a slider. The slider mechanism is actually able to extract some voltage because of the connection. It is it is a concept of series. In series, voltage is divided. After the division, you can withdraw the voltage by a slider. So now you have to copy this circuit, this screen. R1 upon R1 plus R2, this formula is coming from this formula, ratio upon sum of ratios into total. You have to copy this. This is simple. This is a good question. Whatever the slider is covering, whatever slider is covering would be the numerator, would be the resistance on the top. So if the slider is across R1, it will be the numerator. Whatever slider is holding will be the numerator. Now look at the screen and suppose that my input voltage is 10 volt. Okay, and this resistance is 3 ohm and this resistance is 2 ohm. Now I want to know how much voltage I will get here. So for that, you have to understand the concept of simple ratio. In mathematics, we call it direct ratio. Now, how you calculate it, you will put the values here because the slider is across 3 ohm. So you will use 3 upon 3 plus 2 into 10, which means 3 upon 5 into 10, and that it will be 6 volt. So this potential divider will give me 6 volt outside. So it will be a sharing voltage. Now, in our new syllabus last year, they introduced this ratio formula also. R1 upon V1 is equal to R2 upon V2. It is valid for two resistors, and potential divider uses resistors in series. You already have copied this diagram. You have to update the same diagram. It is okay if you update the same diagram and copy these things on it. Now, you can change the position of the slider. Slider is a movable contact. Examiner can give slider in different format. Slider can be in a vertical circuit. This is a vertical circuit. Examiner can give you slider in a horizontal circuit also. So slider can appear in different form. It is not necessary that the word slider is there. slider is actually a movable contact. Slider is actually a movable contact. Whatever slider is covering will take up the voltage. Slider is a movable contact. So slider can take any position. Here, it will be taking the voltage across R1 because it is across R1. You have to copy this screen now. Let me know once you have copied it. Now, this is our next feature in the same potential divider. Remember, potential divider is like a processor. It can decide, it can determine the output voltage. Now, I have introduced a rheostat. In series with a resistor R. I have introduced a rheostat, and this concept needs more attention. It's a bit difficult concept. Now, rheostat is designed to move, and rheostat can be used to change the resistance or the voltage. Now, if you increase the resistance of the rheostat, voltage across rheostat increases because voltage and resistance are directly proportional. But when the voltage across rheostat increases, the voltage across the capital R decreases. It has to compensate because the total voltage cannot change. I repeat this concept. For example, I take the same number. This is 10 volt. If this is 10, it will be 7. For example, it will be 3. Okay. Now you increase the resistance of the rheostat. If you increase the resistance, voltage will also increase. So suppose voltage increases and become 4. Voltage increases and become 4. Then the above resistance will be at 6. Why it is at 6? It has to shift on 6. It has to shift on 6 to compensate the change. This is called the compensator concept. Now, for example, I take the same circuit. This is 10. This is 7. This is 3. Now I decrease the resistance. This relation says that voltage will decrease. Now suppose the voltage will decrease and it reaches 2 volt, then what will happen? The 7 volt will become 8 volt. This is again the same concept that total voltage does not change. The total voltage does not change. This is called the concept of compensator. You have to now copy this screen. You have to copy this screen. You have to update the same screen. R is called compensator. Small r is called internal resistance, and normally in O level majority questions r is not considered. It's a formality there that small r is 0. Now let's talk about this function. Let's talk about this function that when resistance increases, voltage increases. So we have to make a concept map here. The resistance of rheostat, the resistance of the rheostat is increased. We have increased the resistance. This increases voltage across the voltage across rheostat, voltage across rheostat increases. Why this happen? Because voltage is proportional to resistance. So voltage across rheostat increases. As a result, voltage across compensator decreases. Voltage across compensator decreases. Potential divider works like a processor. This is the concept of potential divider. It is a difficult topic and it is coming very regularly nowadays. These all chapters, current, electricity, magnetism, electromagnetism, motor, generator, transformer, they are all difficult chapters. I had started from them because number one, schools are also in the same region, so midterm will be supported. Secondly, these chapters take time to do the past paper, and normally people get problem when they are solving these questions. So we are doing them in advance so that we can cover them later also. Number of resistors can be increased. Number of resistors can be increased as per the requirement. You can increase the number of resistors. You can increase the number of resistors, and you can then move the slider. Look, this is the slider position. You can move the slider here. You can also move it here. So if you have more resistor, you will have more clicking options. You will have more clicking options. You can click more times. More options are there to click the circuit. So just like a regulator of the fan, so you can move it more options. There is another type of potential divider. And it is called single slider. It's a long single slider. You can move it up or down. I show you on my desktop how this slider actually looks like. All of you people must have used it. It's a volume button. Okay. Now you move it like this, you move it back. It is called single slider. Look, it can take all values from 0 till 100. It is not a clicking. It is not a clicking potential divider. It can take all values. It's a single long resistor. It is a single long resistor When you move it up, the distance x increases, and when you move it down, distance x will output voltage will decrease. When you move it up, for example, the famous button on our mobile phones, when you press it upward, the volume increases, and when you press it downward, the volume decreases. Internally, it is a potential divider like this. Internally, it is a potential divider like this. Now you have to copy this screen. You have to copy this screen. Give a new heading, applications of potential divider. Number one, heat sensor. Number two, light sensor. You have to copy this list. There are two sensors based upon them. Now, this is called heat sensor. The first one is heat sensor. Give the side heading heat sensor. Now, it uses thermistor. What is a thermistor? Thermistor, we discussed earlier, it is a heat sensor. It is a semiconductor whose resistance is temperature dependent. Now, look at this screen. This is a resistance and temperature graph, and we call it NTC thermistor. So, right under it, it uses a thermistor. It uses a thermistor. Now, what is a thermistor? Thermistor is a semiconductor. Thermistor is a semiconductor whose resistance is temperature dependent. Thermistor is a semiconductor whose resistance is temperature dependent. So, right under it, the thermistor is a semiconductor thermistor is a semiconductor. We have discussed it before also. So thermistor is a semiconductor. What is the property of this semiconductor? It is sensitive to heat. It is sensitive to heat. You have to copy this. The graph shows that when temperature increases, the resistance decreases. What you have to remember, this is the symbol, and thermistor has a property that when temperature increases, its resistance decreases. Symbol is very important. Examiners, many times it happened that they give you the symbol and they ask you what is the device. That's why I have made a symbol list. I think so. I'm not sure if I made it or not, but a symbol list is to be made, inshallah, if it is not made yet. Now, remember one thing. Potential divider is a concept of resistors in series. Voltage is proportional to R. Why voltage is proportional to R? Because current is constant in a series circuit. You have to copy this screen. Now you have to pay attention to this circuit. It is called a heat sensor. I am using a thermistor in series with a compensator resistor. You have to look it very carefully. This is a difficult concept, and I'm providing heat here. So when the heat is coming on this thermistor, the temperature will increase. When the temperature will increase, resistance will decrease. And according to the relation voltage will also decrease. As a compensator rule, voltage across the resistor will increase. So the output voltage increases. So what happened when heat is falling on this circuit? The device will get more voltage here and this device will switch on. For example, a fire alarm. I repeat from the start again, so please listen it carefully. Heat is falling on the thermistor. Temperature increases, resistance decreases, voltage also decreases. To compensate, voltage increases. The voltage increases means the output voltage increases. So the output device get on. For example, a fire alarm, when heat increases, fire alarm should operate itself. Fire alarm should operate itself automatic. So now you have to copy this screen, copy the whole circuit and let me know once you are done with this big diagram. So let me know once you are done copying this diagram. Yes, Asad, have you done it? So we stop here and inshallah continue in our next class. Allah Hafiz.